Hello, my name is Dante. I work at the minor lab here at UTEP, which is a research laboratory that focuses on skeletal muscle and metabolism. With being asked to conduct a primary research experiment for my RWS class, I went ahead and I put together a little research experiment of my own that I had ideas on, and explaining if neuromuscular electrical stimulation, which is electrical stimulation shock pads, can indeed improve insulin sensitivity in obese people. So to start off with some basics and some basic information, insulin sensitivity is how well your body uptakes and utilizes glucose in the bloodstream. So for those of you, if you eat sugar, donuts, candy, stuff like that, that's sugar that goes into your bloodstream, and then you get a high blood glucose level. So what your body does, it produces a thing called insulin that goes in and reduces the blood glucose levels. That brings it back down to a normal level. Well, those who may be asking the relevance of insulin sensitivity and blood glucose level, to begin with, if your blood glucose level is too high, and it's above 126 milligrams a deciliter, then you are considered diabetic. Or if it's even above 100 milligrams a deciliter, then you're considered pre-diabetic. So it has also been shown that insulin resistance tends to lead to obese and overweight, and also type 2 diabetes. So a thing that has been shown in studies and in secondary research that I have conducted, that I'll show here in a second, shows that physical activity, exercising, walking around, any type of physical activity helps bring down the insulin resistance back down to insulin sensitivity, and helps stabilize your insulin receptors on the cells that make you insulin resistant. So with all that information, I put together that being able to physically exercise and going to the gym all the time is hard for individuals, whether you have school, work, and other personal activities that keep you from exercising. Also, people who are obese tend to lack in physical activity throughout the day. So one thing I've been studying is neuromuscular electrical stimulations, is these little shock pads that you use on the body. A lot of physical therapists, doctors use them for rehabilitation purposes. Some people use it for exercise. I wanted to see is if these neuromuscular electrical stimulations can indeed bring down blood glucose levels and help insulin sensitivity throughout the body. And I put together a little poster over here which shows the data, charts, and everything from my study. Begin with my study, can electrical stimulation, induced muscle contractions, improve insulin sensitivity? I put together this poster. I explained the introduction and background information to you. Methods I did was 8 sessions, 30 minutes, 3 times a week of the quadriceps. So these little red dots is where I placed the electrical stimulations on the quadriceps of obese sedentary individuals. I set it to a frequency of 50 hertz for 400 microseconds, and I put the intensity to tolerable limits to where the patient or test subject could barely tolerate the electrical stimulation. Methods I used as measurements would be the dual X-ray absorptiometry, or DEXA for short, which is a full body scan. It's basically an X-ray. I also did the biodex to calculate the lower body output, when that basically tests the anaerobic power of the legs. So I wanted to also see how strong the legs would get at the end of the study. I also did indirect calorimetry, which is energy expenditure. I used a machine called an RMR, or resting metabolic rate test, to test how well their body utilizes their fats and carbohydrates, how well their body uses substrate utilization. I also did the oral glucose tolerance test, is which the main point where I studied, and that's the test where I could look at insulin sensitivity. Results that I ended up finding is, off the test subjects I had 5 females and 1 male test subject. This is their pre and post: age, weight, BMI, ethnicity. There was barely any change, if not any significant change, to their BMI or height, weight. The blood glucose area and 2-hour blood glucose levels after the 8 sessions, I did not have any significant results, but the p-value of a 0.08 is indeed, after 2 weeks of the study, shows that it is a trend. So later on, I do hypothesize that increasing it to, instead of 2 weeks, to 4 weeks of the E-stem intervention will indeed increase their insulin sensitivity as well as fat oxidation capacities. Off the Wingate and Biodex measurements, I got that their fatigue index did actually significantly increase, as shown right here. And for those who are curious on what a fatigue index is, that is basically how well your body fatigues and how long it's able to withstand that. So the lower it is, the better, which means that the test subjects had more capacity to go and run off the Wingate test. I also did the body composition, which there was no significant change on off 2 weeks, which is honestly has been shown and predicted, because 2 weeks isn't enough time to show change in physical attributes. But on the molecular side, I did see a trend in the insulin sensitivity, and I did see a significant increase in their fatigue index, which is all very good for just 2 weeks of the neuromuscular electrical stimulation. So I do hypothesize if I do increase it to, instead of 2 weeks, to 4 weeks, it'll indeed increase and improve their insulin sensitivity as well as their fatigue index and maybe even body composition. Acknowledgements and references I do have are down here off to the side, and these are my secondary resources that I used for my study. Based on all that, if you guys do have any questions or any comments, concerns about the study, I'd gladly answer them, and I'm right here. Please leave a comment down below. I can answer them as quick as you put it on. I also hope that you guys enjoyed the video and maybe you guys picked something up, learned something, or just found it interesting overall.